Good evening, students. Welcome back to our session on trigonometry. So, please let me know, guys. Are you guys there or not? So, please just give your attendance so that I could able to know who and all will be there in the class. I guess we have missed our three sessions, I guess. So like last time I got some work, so because of that we just had to cancel our class. So for trigonometry, so with this by this session we'll be completing our chapter of trigonometry. So I guess no one is here, so I'll just wait for few more minutes. So if anyone is there, so please let me know, guys, so that I could able to know who and all are there for the class. So I don't know if someone is there or not. So let me just wait. I don't know what's happening, guys. I'm not able to getting you, so I don't know whether you guys are there or not. So I'm not sure what's happening. Hello, ma'am. Today I have actually 11th standard class, but I'm streaming also, but no student came, so I don't know what's the reason. Yes, ma'am. Actually, hello. Pawan sir told me today only, like regarding this 11th standard, we are planning to shift the timing so that student. Yeah, I know. But now there are no students. That's why I just asked you. Okay, ma'am. Then just let me know once they came so that I can start. Hello, students. So welcome back. So I just know that we have discussed in our previous session 6 and what we are going to cover in our today's session 7. So as I told you in the previous session, I have given a quick what we can say definition of, right? So we actually have a bit of confusion. That's natural, right? But when we are having an examination, we won't get off our today's session. We are going to deal with the methods of solving trigonometric equations. So there are actually different types, like we can say different methods to solve our trigonometric equations. So why we actually have different methods? Because all trigonometric equations will not be in a same typical manner, right? So it will be different from each other. So for those typical equations of one particular equation, we can follow one methodology to solve that equation. Similarly, for some standard types of trigonometric equations, we will be having some standard methodology. Right, so similarly, like we can say, if we take our, what we can say, linear equations itself. For linear equations also, we are having different methods. I guess in your 10th standard, you might have learned of solving those linear equations using different methods. So for example, one method will be elimination method, and one method will be the substitution method, and the other will be squaring method. Right, so those are actually different methods we can use to solve a linear equation. So similarly, according to the equation here, that's the difference here for trigonometric equations. Because for linear, in the sense, we'll be having only two variables x and y with some standard coefficient. But that's not the case when we are dealing with trigonometric equations. Because here we'll be having some angle. The angle will be different from each other and different trigonometric ratios we'll be having. So when compared to our linear, our trigonometric will be obviously different from that linear equations. So for these typical trigonometric equations, we are having few methods of solving them. Right. So today we'll be seeing the different methods of solving different trigonometric equations. Right. So that will be our major aim for today's session. And after that, the last but not least the topic. So the last topic here we are going to deal is extreme values. I have already given a quick intro of what are extreme values in our previous session, also factorization. So what is our first method? The first method we are having here is nothing but a factorization method. So by the name itself, you might have get an idea, is nothing but we simply factorize our trigonometric equations. And using that factorization, we will be solving our given trigonometric equation. So I guess you people are aware of what is factorization. I am sure, because for example, if there is a quadratic equation, you know how to factorize that, isn't it? So in the same typical way, you can consider your trigonometric equation and square x. So how can we solve this using our factorization? Right. So first what we can do, so to get a factorization, to apply our factorization, what should be our equation look like? So our equation should be such that our RHS to be equal to 0. So let me rewrite this equation. So 2 sin x minus cos x into, so 1 plus cos x is equal minus sin square x is equal to 0. Right. So now what you can do? So can you guys think of it? So how we can solve this further? So how can we reduce this such a way that we could factorize this given function? Any ideas? So let me give you a quick 1 minute to think over it. So just give it a thought. And what can be our next step? Can you guys try? Any idea? Okay. So here, by seeing this first step here, cos and 1 sin. So there is no typical common to take the factorization method. But here if you observe, there is a sin square x. So we are having an identity which states that cos square x plus sin square x is equal to 1, from where our sin square x can be written as 1 minus cos square x is nothing but our sin square x. Isn't it? So now I'll be using that particular identity to replace my sin square x. So 2 sin x minus cos x into 1 plus cos x minus, in place of sin square, what I'll be writing? 1 minus cos square x using the standard identity. So here, this one I can write it as 1 square. So if I can write this as 1 square, then it will be 1 square minus cos square x, which is in the form of a square minus b square, which can be equal to a plus b into a minus b. So now we'll just expand that. So 2 sin x minus cos x into 1 plus cos x minus, so here it will be a plus b into a minus b, isn't it, according to our formula. So it will be 1 plus cos x into 1 minus cos x equal to 0. So now if you observe these two terms, we can actually have a term common, that is nothing but 1 plus cos x. So I am taking out this 1 plus cos x as common, then I will be having 2 sin x minus cos x. So if I have taken this common, then it will be minus will be there, right? So minus 1 plus cos x equal to 0. So plus cos x and minus cos x will get cancelled, and we will be remaining with 1 plus cos x into 2 sin x minus 1 is equal to 0. Right. So now if you observe from here to here, which means we have simply factorized our given trigonometric equation, isn't it? So now we have to write the solution of it. So I guess until now you are clear with it. So due to this message issue, I am not sure whether you guys are following or not. So I am assuming you guys are following. So if you have any doubts, so we can discuss, just keep a note of them so that we can discuss once this messages issue has been clear. Right? Okay. So I'll just write the solution here. Yeah, we got the expression after factorizing as 1 plus cos x into 2 sin x minus 1 is equal to 0. Which means our term 1 plus cos x is equal to 0, 1 or 2 sin x minus 1 equal to 0. So from here cos x will be equal to minus 1 and from here sin x will be equal to 1 by 2. So now we can write our solution. So when our cos value will be minus 1 at 180 degrees. So cos pi. And when our sin value will be 1 by 2 at 30 degrees. So sin pi by 6. Right. So from here, if we are trying to write our general solution, then it will be cos theta equal to cos alpha, where our alpha is pi. So according to this, it will be 2n pi plus or minus pi. Right. So 2n pi plus or minus pi. And what about our sine? So for sine, it will be x is equal to n pi plus minus 1 whole power n alpha, that is pi by 6. Right. So here you can take pi common also, because here you can observe pi common, or else you can leave it like this. So for both our n belongs to integers. Right. So hence our solution of the equation is nothing but x is equal to, we can take pi common, then it will be 2n plus or minus 1 into pi, n belongs to integers, or x is equal to n pi plus minus 1 whole power n pi by 6. Right. So what we have done, from this given typical equation, we have used our factorization and reduced and rewritten our equation as in this form. And we have two conditions here, 1 plus cos x equal to 0 and 2 sin x minus 1 equal to 0. And then we have reduced it such a way that we end up having our form that is cos x equal to cos alpha and sin x is equal to sin alpha. And we know how to write the general solutions here. You have to keep in mind that whenever they didn't mention you to find the principal solution, you have to always find the general solution. If they haven't mentioned as principal solution, or else if they haven't given any particular interval where you have to find the x, then you have to go with the general solution only. So like how I have just written the general solution for this typical question. Right. So now I guess you guys are clear with this method of solving, that is our factorization, using the factorization solving our trigonometric equations. So getting into our next method of solving equation, that is our trigonometric equation, is nothing but sum to product. So what is the sum to product? So this sum to product is nothing but basically here. So here this trigonometric equations can be solved by transforming a sum or difference of trigonometric ratios into product. So sum can be transformed into product. So for example, I can give you a formula, that is sin c plus sin d. So this is sum. So how we can convert into product? So 2 sin c plus d by 2 cos c minus d by 2 product. So basically you have to look over all those formulas which involves this sum to product conversion. Right. So simply we'll be applying these formulas to our given equations and converting from one form. In this method, what we have to do is we have to combine our formula and then we can see we can apply our general solution formula. So we'll just do one question here. Sorry, it's the same one. I'll just give you one more question here. Okay, let me write. So this question has been repeated here. I'll just write one more question. Yeah, solve cos 3x plus sin 2x minus sin 4x is equal to 0. So just leave this question. This question we have already solved it. So yeah, so solve this question. So the question here is you have to solve for x, that for the equation cos 3x plus sin 2x minus sine 4x. So I have even given you the hints for the formulas, what and all you have to use. So I'll just give you some time so that you can think over how to solve this question, because there is nothing new here. The only thing is you have to apply your some formulas and to convert them such a way that it will be becoming into a product form, and then you can simply apply your general solution formulas. Okay, quickly try to solve this question. I'll just give you a few minutes. So I don't know whether you guys are solving or not, but I know you will be solving, but I'm not sure how much time it will be taken. No issue, I'll just wait for 5 minutes and then I'll explain you the solution here, because you might have some doubts and all. So as we doesn't have this text opportunity now, so I can just simply solve and give you the answer. Yeah, for now you just take 5 minutes and try to solve this question. So just simply apply your formulas. So here what formula you can apply here? Here if you observe, we are having a basic sum formulas for sin C plus sin D, sin C minus sin D, cos C plus cos D, cos C minus cos D. So here we are having two sines. So you can apply the formula of sin C minus sin D, which is equal to 2 cos C plus D by 2 sin C minus D by 2. So you can apply the formula here and you can try to convert that into simplest form here. So I know you guys are solving it, so that I am just giving you few more minutes. Okay, it's already been 5 minutes. So I have even given you the hint here. So I'll just solve this question and let you know. So here, as I told you, we'll be applying the formula of sin C minus sin D. So cos 3x will be remaining as it is. So here, according to this, so 2 cos, so C plus D means 2x plus 4x by 2 into sin 2x minus 4x by 2. Right. So here if you observe, we have converted this sum, we can solve difference, sum difference to product. So we are converting this to product. So here it will become cos 3x plus 2 cos 6 by 2. So it will be 3x. And here sin of minus 2x. So it will be minus x is equal to 0. So we will be having cos 3x minus 2 cos 3x sin x is equal to x 0, because sin of minus x will be x is equal to 0 or 1 minus 2 sin x is equal to 0. So now for cos 3x is equal to 0, what is our general solution? It will be 2n plus 1 pi by 2. Right, so 2n plus 1 pi by 2. So but here in place of x we are having 3x. So it will be 3x. Right, so this is for cos x. So we have to find the solution for x. So it will be 2n plus 1 into this 3 will be coming here pi by 6. So this is from cos 3x. So similarly what about here? So it will be is equal to 2 sin x and sin x will be equal to 1 by 2, which means sin x will be equal to sin pi by 6. So again we can write this general solution, that is nothing but x is equal to n pi plus minus 1 whole power n pi by 6. So now what is the solution for this question, that is cos 3x plus, which we have actually converted that into product of trigonometric ratios. Right? Yeah. So product. So we have converted the difference into the product. So this is the typical second method, that is nothing but sum or difference to product. So this is all about the second method. I guess you are clear with this concept also. So if you have any doubts, please keep a note of them so that you can ask me in the later sessions. So the third method here. So the next method is the reverse of our previous. So product to sum or difference. Right, so product to sum or difference. So what happened in the previous method, what we have done? We have converted the sum or difference of trigonometric equation. Answer this by converting this product to sum or difference. I'll just give you 5 minutes, guys. So here they have given in terms of product, you have to convert that into either sum or difference. Yeah. So same formulas will be applicable here, but in a reverse manner. So just give it a try. Same typical formula. I think you can answer this question. So please try this. So simple formula here. Here I'll just again give you the hint for this also. So here if you observe sine and cos. Here sine and cos. So it will be obviously either sum or difference. So you have to identify the angle such a way that it can be either you can write that as sin c plus sin d or sin c minus sin d. So these two cases are possible. So which will be the correct one? You have to identify that. So sin 5x cos 3x. So there is no 2. So I am multiplying with 2 and dividing with 2. So here also the same thing. Dividing by 2 and multiplying by 2. So sin 6x cos 2x. So if the first term here sin 5x is in the form of c plus b by 2, then this complete term is nothing but 5x, which means c plus d should be equal to 10x. And in the same way, c minus d by 2 here should be equal to 3x, which means c minus d should be equal to 3x. So here for this first one, you got the condition, that is c plus d should be equal to 10x and c minus d should be equal to 6x. So simply solve these two equations. So 2c, so here it will be 2c is equal to 16x. So c will be equal to 8x. So if c is 8x, then d will be 2x. The RHS terms here, how I have found out here, the same manner you can apply and get the equations and solve it. So here c plus d by 2 will be equal to 6x, which means c plus d will be equal to 12x, one condition, and c minus d by 2 is equal to 2x into sine 8x plus sine 4x. So here if you observe, these are the trigonometric ratios in product which we actually converted them in terms of sum. Right, so I guess you understood this step. So the only trick here is, if you understand the first step, then we are done with the question. Right, so now the next one is simply solving it and applying our equations, general equations or principal form, any of it. So this 1 by 2 and 1 by 2 will be getting cancelled and it will be sine 8x plus sine 2x sine 4x is equal to 0, and we can apply our formula again here. So that means 2 cos, so 4 plus 2, 6 by, so it will be 3x, and sine, so 2 minus 4, so minus 2x by 2, which means minus x is equal to 0, which implies minus 2 cos 3x and sine x is equal to 0. So this will be our least reduced form for this typical given equation. So we end up having minus 2 cos 3x into sin x is equal to 0. So let's write the solution here. Yeah. So minus 2 cos 3x and sin x is equal to 0. So from here 1 will be sin x is equal to 0 and the other will be cos 3x is equal to 0. So from here x will be equal to n pi plus, sorry, directly n pi. Sin x equal to 0, we are having n pi, right? So directly we can leave it as n pi. And for 3x it will be 2n plus 1 into 1 by 2 because our RHS is 0. So here x will be equal to 2n plus 1 into pi by 6. Right? But here what you have to find? You have to find the values in between the interval 0 and 1. So you have to give the values for n. So what happens when n is equal to 0? So n is equal to 0, it will be 0. So our x values will be 0. When n is equal to 1, it will be pi. So that will also be considered. And we will be having pi by 2 and pi by 6. And we can even have 5 pi by 6. So these we are getting by simply taking our n values and substituting there. Right. So as here they have given in the interval. So basically what n values, our n values belongs to integers. But here you can't take the negative integer. Right. If you take the negative integer, your angles will also be coming into the negative, which we doesn't want because they have mentioned the interval. So you can take 0, 1, 2, 3 and so on you can take and you can substitute here. Right. So these are the 5 values we'll be having as the solutions for this given equation. So the number of solutions they have mentioned. So the number of solutions here are nothing but equal to 5. So once you are done with solving it, it will be easy to write the final answer here. So this is our third method. So till now we have learned 3. So the first one will be a easy factorization and the next one will be sum or difference to product and the next one will be product to sum or difference. So the next final method of solving is nothing but parametric method. So here I have written a clumsy equations which actually make you think what is this parametric method. What we'll be doing is we'll be substituting some other values in place of A and B. So here it's a typical proof we can say. So in place of A, we'll be substituting R cos phi, and in place of B, we'll be substituting R sin phi. Then it will be becoming into a format that is R cos phi is cos theta plus R sin phi sin theta is equal to C. Your R here is nothing but root over A square plus B square. And so this is a proof. You can understand this as a proof. So here in place of A, we will be substituting R cos phi, and in place of B, we will be substituting R sin phi. So here if you observe, this is in the format of cos of theta minus phi or not. Right, so when we take R common, so when we bring it here, it will become C by R, and in the LHS, so if our mod C is greater than root over A square plus B square, then this equation has no solution. So here are the conditions here. Right, so if it is greater than this A square plus B square under root, then this equation of trigonometry doesn't have any solution. So if in case it is less than or equal to, right, if it is less than or equal to, then what we can do? So we'll be substituting 3 by mod C by root over A square plus B square as cos alpha. So that means we'll be having cos of theta minus phi, which is equal to C by R. R is nothing but root over A square plus B square. So in place of this, we'll be substituting cos alpha. Right. So, but it's like by taking this A as what we can say A cos alpha, B as A sin alpha. These are actually a typical tricky ways. So I'll just give you a simple way of solving this parametric method. Right. So here this is the question. So the equation is in the form of plus B sin theta is equal to 3. So you can divide the whole expression by root over A square plus B square. So if you divide this complete expression by A square by B square, you will be having some terms here, and that you can convert in terms of our trigonometric ratios. So I'll just solve one question to make you understand easy. So here it's the first question, sin x plus root 3 cos x is equal to root 2. So here our A value is 1, B value is root 3 and C value is root 2. Right. So, yeah. So our overall aim is to convert this either in the form of cos of theta minus phi or theta plus phi, something like that. So what we can do, first we have to check our A square plus B square under root value. So that is 1 square plus root 3 whole square. Then here. So we have verified our first condition, whether the equation is having a solution or not. So our next step is, with this R value, we have to divide the complete equation, which means sin x by 2 plus root 3 cos x by 2 is equal to root 3 by 2. So now simplify it. So it will be 1 by 2 into sin x plus root 3 by 2 into cos x, which is equal to 1 by root 2. So our overall aim is we have to convert this into our formula. Right. So now here which format you can say? So here I can write this 1 by 2 and root 3 by 2 in terms of my sin or cos. Right. So if I try to write this in terms of cos, then I should have, what is my formula for cos of A minus B? That is equal to cos A cos B plus sin A sin B. So I can follow this. So here sin x is there. So I have to write here again sin x. So what is this 1 by 2? 30. So that means sin pi by 6 is nothing but 1 by 2 into sin x plus cos 30 is also root 3 by 2. So cos pi by 6 is also root 3 by 2. So in place of root 3 by 2, I can substitute cos pi by 6 into cos x is equal to, so 1 by root 2 I can write it as cos pi by 4 because I am writing in the formula of cos of a minus b. So it's up to you. You can convert it into sine of a plus b also. There is no issue. It's up to you. So now my format here is cos of a, that means pi by 6 minus x. So this complete expression can be replaced and written as cos of pi by 6 minus x, which is equal to cos of pi by 4. So now I am having my expression, that is cos x is equal to cos alpha. So according to this, my x will be equal to 2n pi plus or minus alpha. So alpha here is pi by 4. So but I have to find for x, right? So here if you observe, if I have taken minus common here it's a minus, right? So instead of writing like this, what I can do is I can take minus common in the previous step only, because here it's a plus or minus, so it will be clumsy when we rewrite it, right? So I'll just erase this and write it. Sorry. Yeah, so we are having cos of pi by 6 minus x, which is equal to cos pi by 4. So that's our previous step. So here I am taking x minus common, so it will become x minus pi by 6 is equal to cos pi by 4. So cos of minus x is nothing but cos x. So it will be cos x minus pi by 6, which is equal to cos pi by 4. So now it will be easy for me to write it. So here it will be x minus pi by 6 will be equal to 2n pi plus or minus pi by 4, and x here will be equal to 2n pi plus or minus pi by 4 plus pi by 6, which is nothing but 2n pi plus or minus 5 pi by. So you can leave it like this. Yeah. So this will be our solution, right? So here the thing is, basically for these typical types of parametric form, the answer, the procedure which we follow is actually based upon our what we can say, options. Why? Because in the previous step, if you observe, I have written here 1 by 2 sin x plus root 3 by 2 cos x is equal to 1 by 2 root 2. Right, so here what I have written, in place of 1 by 2 I have written sin 30, but I can even write cos 60, that means cos pi by 3 into sin x plus, here I can write sin pi by 3, that means sin 60 also root 3 by 2, cos x here sin pi by 4 also, but here this is the formula of sin a cos b plus cos a sin b, which means sin of x plus, here it will be pi by 3, which is equal to sin pi by 4. So our general solution will be changing, right? So that's why based upon options you have to go, right? So generally sometimes you can get a multiple option answer. There you have to solve in these two methods and you will be getting the answer. So that's the only trick here for this parametric form of trigonometric equations. So there will be two types of answers which we might get for a general equation. So that we have to keep in mind. So I have shown you the previous one by converting into the formula of cos a minus b. But here I have converted into sin of a plus b. So which means in two types we can actually convert the given trigonometric equation. So this is all about our methods of solving trigonometric equations. So there is one more question here. So I guess you guys can solve it. Take this as a homework. So I am just giving this question because today due to that messages issue where I haven't given you any time to solve question. So I am just giving you some homework for today's session. So just solve this question. Take this as homework. So this one, and you have to take this also as homework and solve this. So I am giving you two questions as homework, and Yeah. So our next topic here is extreme values, that is nothing but maximum and minimum. So there is nothing to here. So there are formulas which are given to find the maximum and minimum values for some standard trigonometric functions. So the first case here is, so the derivation of these things, it's a product. So the previous case is, it's actually relation of the trigonometric functions in terms of sum. But here it's a product which is given by cos theta into sin theta whole power n. And the maximum value can go up to infinity because as it's in a power, it can go up to infinity. But the minimum value will be always constant here. That is given by 1 by 2 whole power n. Right, so as in power n, so it will actually go to infinity, the maximum value, but the minimum value here will be always 1 by 2 whole power n. So this will be the second case. So the first case is our sum relation of our cos and sin functions, and the next one is our product relation. And the third case is squares. So squares of our sin and cos. So that is a sin square theta plus b cos square theta equal to 0. So it will be an equation. Right. So it actually based upon the coefficients here. So the maximum and minimum value will be based upon the coefficients. So if our a greater than b, then maximum value will be a and minimum value will be b. If it's the reverse case, then the maximum value will be b and minimum value will be a. Which means whatever value is maximum among these two, that will be the maximum value and the other will be the minimum value for these typical equation functions. That means our sin theta can be written as 1 by cosecant theta, isn't it? And similarly, our cos theta can be written as 1 by secant theta and our tan theta can be written as 1 by cot theta. So here in our fourth case, we are having relation for these corresponding functions. That means squares of these corresponding functions. So here you can observe a sin square theta plus b cosecant square theta. Similarly, a cos square theta plus or minus b secant square theta, and the third one is a tan square theta plus or minus b cot square theta. So this relation you can remember easily. So that's why I have shown you these relations, because these relations we have already known other of these relations. So to remember this case for these relations allow us to make it easy. Right, so if you can find any trigonometric relation like this, then our maximum value will go up to infinity and our minimum value will be 2 root over 8b. Right, similarly for our product also we have seen maximum will go up to infinity and minimum will be 1 by 2 whole power n, and here the minimum will be 2 root over ab. So these are the typical 4 cases which we are having for our trigonometric equations, where we can find the maximum and minimum values for these trigonometric equations. So let's solve one last question based on our extreme values, and then we can wind up our chapter as well as our session. Yeah, so I'll just give you 2 minutes time so that you can give it a try by your own. You can identify which typical case is this and what is the maximum value. So they have asked you for the maximum value. So here we are having relation of cos and sin, and it is in the form of a sin theta plus or minus b cos theta plus c, which means this is our case 1. That is our first case. So for our first case, what is the maximum and minimum value? So let's just find both. So maximum value is given by c plus root over a square is nothing but 2 square plus 4 square, that is 4 plus 16, that is equal to root over 20. So let's just see, can we reduce this? So 5 into 4 So 2 into 2. So we can write this as 2 root 5. So our root 20 can be written as 2 root 5. Right. So we got our value of root over a square plus b square, that is 2 root 5. So here our maximum value will be c. What is our c value? That is 3. So 3 plus 2 root 5 will be the maximum value, and as well as the minimum will be 3 minus 2 root 5. Right. So this is the typical way of asking questions for based on this extreme doubts from this session. Please let me ask those questions in our next session so that I can clear you. And if you have any queries and questions also, you can ask me in our next session. Right. So please do the 2 homework questions and let me know if you are facing any troubles or not. So with this, we have finished our chapter of trigonometry. So as we have finished our chapter trigonometry, so there is a worksheet which contains 30 questions according to the JEE mains pattern. So I will be sending you the worksheets so that once you like, it's be like a practice for you. So yeah, so I'll just upload the worksheet of this particular chapter trigonometry. So yeah, so with this we have finished our chapter trigonometry. So in our next session we'll be starting with a new chapter. So thank you.